fantastic to be here. This is my first Google Fest talk in Minnesota. And I'm thankful to you guys that you're staying here after lunch. I would not do that. So, even though the title of my talk is dramatically incomplete, I learned this from experience that catching people's attention is hard. So I tried making it fancy so that I can draw a few of them here, which I think work. So I'm going to be talking about modern web application architecture, but a little bit about me before we get started. My name is Raza Firdousi. I'm a troublemaker at PayPal. I'm an active community member of the Angular community in Silicon Valley. I'm originally from Pakistan, so pardon my English if you will. I try to manage some open source communities remotely from here. I have around 10 years of experience building large-scale enterprise applications, data-centric applications. And a lot of the things that I'm going to be talking about today are coming out of the experience that I've had building those large-scale applications. So I have around like 271 million followers on Twitter. That M looks fake, right? It's fake. So help me get that. Thank you. So quick show of hands. Who on earth has ever heard of the term single-page applications? Even if you have heard of it, never worked on it. This part is nice, you guys. Awesome. So keep your hands up. If 70% of the stuff that you do the whole day is single-page applications. That's quite awesome, and that's what I always predict, that hands might go down on this question, which just happened, so good to know. So a little disclaimer before we move forward. Although I am from the Angular community, I don't want to mess up this talk by talking only about Angular. So I had all these frameworks on the slide to give them an equal opportunity. I'm not going to be talking about any of them. I don't know who's using Backbone and Knockout still, but anyways, just to give them equal chance. So let's do a quick refresher of what is a single-page application, just to set up the mood. So you go to your browser and you make a request to the server. Server might want to talk to the database and then comes back with something, which is a HTML page. The browser takes some time to render that, and then you have something on your page, right? Now this page is something which stays in the browser for the entire lifetime of a single page application. And that's why we call it a shell page. So the next time you make a request to the server, now this time you're not requesting for a whole HTML page, but you are mostly requesting for a chunk of some data, some JSON data, a chunk of an HTML or an image or something like that, which you kind of bring back to the browser and appends on whatever you already have in the browser, right? And this is how Ajax works. So you have a JSON or an image or something like that, and then you bring back on data on the page. Only that part of the page reloads, and then you have a new view. Now there is something called routing in single page applications. So you move from one route to a new route, and then you see a different form of the page, right? Now, so this is what a classical MVC model is, right? So what you see in the middle is what the user sees, which is a view, right? This side we have model, and the other side, please help me, move my hands. So this side is the model, and the other side is something which is controversial. That makes MVC, right? So the whole talk today is going to be about this controversial part, because I think there are a number of ways you can do models and a number of ways you can do the views. I'm not going to be focusing on them, so just keep that in mind. Now, let's move forward. So I'm interested in starting with the C part, unfortunately called controller, which is how you determine behavior on your page, right? We'll discuss along the way why it's unfortunate to be called a controller. The model and the view, you can do in any number of ways, right? So that's why I want to focus on this controversial part first. So this event is sponsored by Google. I thought it would be great if I can come up with a real-world application rather than talking about the whole thing in abstraction. So congratulations, we're gonna be building YouTube from scratch in 40 minutes. Don't tell anybody. So I'm so super excited about it that we'll be discussing the YouTube interface and how it can be done. But so I'll take some time before that to discuss why I'm starting with controllers. So there are two reasons why I like discussing controllers first. It's really good for single page applications where you have a bunch of functionalities on the page and you go from one route to the other. And then also when you have an application with multiple pages, right? And those multiple pages are kind of sharing similar functionalities. So controller can be good for both. That's the reason why I'm starting with the controller. So what I'm really talking about here is building an application framework. Now don't tell me that application framework is equal to front-end framework. So application, Ember, Angular, Knockout, React, whatever, those are not application frameworks. Those are something on top of which you can build application framework. So it's actually a layer that sits on top of your base library, and your base library can be anything, starting from jQuery and going up to all these fancy frameworks that I talked about. And I'm not talking about a specific framework. I'm not here to promote anything in particular, but just an architectural approach that I would love, and then I would love you to go back in your organization and build an application framework that suits your application and your organization. So let's move. So I want to think of application framework as a playground. Apps do a ton of things, right? That are kind of related, but not really always related. So an application framework helps you tie all of that together in some sort of meaningful way. So the question arises, isn't that what all JavaScript frameworks do? So whenever I talk about this, I get this question, right? I already do this with Angular, don't tell me about this. So people come and tell me, well, I'm using jQuery and that's an application framework. Some other modern web application developer comes and tells you, you know what, Angular 2 is awesome. I don't want any application framework. But all these libraries provide you with tools to build an application framework and do a lot of other things. So just like having a toolbox, you got to know what stuff you want to bring out of the toolbox and bring your stuff and make up your application, right? So this is some good amount of talking that we have done to start with. I'm going to be building this complex YouTube application, trust me. And I'll be referencing this application throughout. Let's take a look at how YouTube looks today. This is how it looks, by the way. I'm also going to be referencing this architectural diagram all over my talk. So you have your base library or a JavaScript framework library, which can be any library you love, and then the application framework, the application core is built on top of that. So there are two distinct layers. I'm trying to emphasize this much so that you keep this in mind. But before we talk about all of this, let's talk about the module theory. So I googled what are modules and I got a bunch of boring definitions out of Wikipedia. But the most interesting one was an independent self-contained unit of a spacecraft, right? That was the most interesting one. So let's talk about this beast for a second. It's giant, right? It's huge. And the interesting part is, how did they take this gigantic piece off of the Earth into space? It's really hard, right? You need a lot of energy, you need to beat gravity, you need to beat air pressure and whatnot. And the answer is, you separate it out into modules, into small pieces. Then you shoot them out in the air and then you combine them in the outer space. I'm not an astronaut, so don't come after me, by the way. So now what we have done is we have broken down the problem that was previously massive into small pieces that are testable and then can be combined to make something as complex as this beast. Complex applications like YouTube are built almost the same way. So let's take a look and see what are the different modules we can see on the YouTube's page. So the search can be one module. this part can be another module. And then this thing, and then you have this channel subscription thing, which can be another module. And then these menus up top, and then you have this recommendation place, and then you have a bunch of other stuff like upload button, and then the login area, and then the YouTube logo itself. So I'm not saying this is the way it should be done, or this is the way YouTube team has done, but I'm just saying that this is a way that it can be done. This is a way that it can be broken down into pieces. And this blue box is the shell page that I already talked about. So all these small pieces live in a big container, and that container stays there forever, and these small pieces come and go. They can be dynamically loaded, or they can be loaded when the page loads itself. So each module on the page, as you can see, has its own HTML, its own CSS, and its own JavaScript, right? We are focusing only on the JavaScript part, but just to keep that in mind, that all what we're talking about is this entirely small page which sits in a larger page, right? So what are the properties of a module? Any single module should be able to live on its own. And when I say live on its own, what does that mean? It means that if I take that module out of the page would work fine. If I bring that module into the page still works fine. So taking a module in and out will not break the whole big container. So this is what a module is. So a module needs to be independent. It needs to be loosely coupled, standalone, and then it needs to be ultra testable. Have you ever heard of the term ultra testable? Me neither, by the way, I just invented that. So this is the module I'll be focusing on for testing. So there are a bunch of testing that you can do. You do unit testing, you do quality of service testing. By the way, for this, there's a friend of mine who works at Google. He works especially on the search thing, and their quality of service is you type in something in this text box, and then they kind of calculate how good was the suggestion that you see on this page. So this is their quality of service test that they do quite a lot. And then you have the bunch of integration testing, regression testing, all this stuff. But let's talk about unit testing for a bit. Maybe let's see some pseudocode. We got to build YouTube, by the way. So every ultra testable module has three things: a well-defined input, a well-defined dependency, an array of dependencies, and a well-defined output. So let's see if we can have some code in here. So on the top you see I declared a module. By the way, this is no language, this is no JavaScript, this is no framework, so don't come and ask me what framework is it. This is just some pseudocode. So this is how we declare some module, and then we define dependencies, and then we have clearly defined inputs and outputs of that module in the definition, right? And then we have a bunch of functionalities. So we have the search result, which is a functionality of this module. Now in your test suite, you can easily swap out the real services with some mock dependencies. Has anybody ever done like unit testing? Everybody knows what mock objects are? I think people know. So yeah, so when you're writing the test, right, you can actually swap this dependency into something which is fake, right? Which looks real, but it's not real. And this is very important when you do modules. I'm not here to talk about unit testing, so you can go ahead and look at this guy's stuff. He has done some good amount of talking on how to test single page applications specifically. So you can take a look at that. So we talked a bit about the kinds of testing we covered, right? Next thing we're going to talk about is loose coupling. So let's talk about that. So as we build our application, you'll be creating tons of modules, right? Literally tons of modules. And the last thing you want to have happen is a guy on this team does something on one module and then checks in, and then these 5 people who are working on the other team building some other module, everything breaks there. And we do that every time, right? That's why I call myself a troublemaker. I do that all the time. So that's exactly what you don't want, and that's exactly what happens when your modules are tightly coupled. So what you ideally want is you should be able to make a change in your app, and you know that it will just work, and it will not affect any other module, right? So how do you achieve that? Each module on the page has its own sandbox, which basically limits what a module can do. And I'm afraid at some point in time somebody will ask me a question, how do you do that in JavaScript? Like everything is shared, right? Everything is global, all the variables go global. How do you kind of make these separation to the boundary, right? So there are three ways to go about it. You do it by convention. If you have a bunch of people on your team and you know that they listen to you, then you can actually confirm on something that, okay, I will not do this, I will not do that, and you don't do this. This is one way, and it really works when it comes to JavaScript. You can also use some post-code validation tools. If you have heard of ESLint, you can use that to make sure that you don't kind of interrelate one module into the other, so that it ensures that you're not doing any tight coupling. And also now you can take help of IDEs like WebStorm, if you've heard of it or used it. You can actually make it work in a way that it helps you avoid any tight couplings like interdependencies between the modules. So the base library and the application core, I'm going to throw on top of that the sandbox. The sandbox is basically a very thin layer. It does not have much functionality, but all what it does is it gives you an interface to the application core. And then you have multiple modules surrounding this sandbox. So these are the four things we're going to be talking about: modules, sandbox, application core, and the base library. So the modules. Modules have very limited knowledge of what's going on in the entire application. So they're like pieces of a puzzle. They don't know about the whole picture, but all what they know is what they do, and that's it. They only know that they have a sandbox and they can use it to do a bunch of things. And this is very important, and this is where I see a lot of application frameworks in the past fall flat, is that when modules know about each other, that means that they're tightly coupled. Every time you change one, you probably have to change the other and also test the other. That's really bad, especially when you're on a team which is kind of scaling and a project which is scaling. When something is done, it needs to be done. So we already saw the pseudocode of how you might declare and define a module. Remember that? I'm calling it pseudo because it's not coming out of any library. It's just a pseudo implementation of how it might look like. So our module depends on the dependency listed in the dependency array. What exactly is it? This is, my view, is the sandbox for your module, right? All those dependencies, which are in Angular called services, and in other frameworks I don't know what they call. And do you see what we pass in the parameters? It's the dependency. So when you define, you pass in your whole sandbox, right? So your module has access only to the sandbox that you pass in. And then in the search result function, this module can use the sandbox to do a bunch of functionalities. Other than that, we already have, we can also talk about lifecycle hooks in modules. These are very important, and all the frameworks have these. Like, what happens when this module loads? What happens when this module is destroyed, right? Because you might want to load the modules dynamically, and you would like to do something when they're destroyed or when they're initiated on the page. It's not necessary that you always load the module when the whole page loads, right? So there are a bunch of scenarios where you actually load them dynamically, and these live hooks are very important. So you already saw all parts of the module, right? The declaration, the dependency, the definition, and then a bunch of functionalities. So which part of this module know about the whole web application? Did you see other parts of the application within the module definition? You did not, right? It's not important. You should think about the module as pieces of puzzle, I said, right? They don't care about what the whole application is. They only care about their particular functionality. As long as the puzzle pieces are in the right shape, then it's doing its job. And part of this architecture the same way. So what are the jobs of a module in conclusion? So if you're a subscription module like this, it's your job to tell people about the subscribe channels. If you are a video recommendation module, it's your job to give recommendations to people. Each module's job is to create a meaningful user experience. And that's the overall web application's job as well, right? This does not mean actually that modules can do whatever they want. They have to follow some rules, because if they don't, you will end up in the mess that we have been talking about. So these are, I would say, the 4 main properties of a module. Hand to yourself. Now what does that mean? Only call your own methods or those on the sandbox. So I showed one method called search text defined within the module, right? So you can call that method, or you can call any method that is present in the sandbox, because you only have access to the sandbox. Never access the DOM. Only ask if you want to access the DOM from the sandbox. So the second point is ask, don't take. So if you need something else that a module cannot do themselves, then ask the sandbox for permission. For example, like a module showing up only if the user is authenticated to see that or not, right? So the module cannot itself decide that whether the user is authenticated to do that or not. You have to use some sort of external service and ask that sandbox whether I should show this module to the user or not, right? So it's not its own job, right? It's the job of the sandbox. Don't leave your toys around. Like, don't create global objects, because that just creates a mess for everybody. And then lastly, don't talk to strangers. Don't directly reference other modules, and keep it as loosely coupled as possible. But people come and tell me that this is too restrictive. But trust me, you can literally do that. But when you start talking to people about that, you have a lot of angry birds in your team telling you that it's too restrictive and it's not, I mean, how would you do that? I cannot be so confined to your rules and regulations. But down the line, they start seeing the value, right? When you can easily scale out your application, and we'll see that in a bit, like a bit of code. So sandbox up at the top of the architecture. Its only job is to ensure a consistent interface. It defines the way modules interact with the world, like with the application core. If the module really only needs to deal with the sandbox, then it really does not matter what goes on at any other place, at any other stack. What goes on, it doesn't matter, as long as it's only contacting the sandbox. So, let's see. So, yeah, this is important. So, since sandbox is the only thing modules know about, sandbox also acts like a security guard. So, if something is allowed for a module to be done, it's only decided by the sandbox and nobody else. So let's see at some code. So here is your channel module, which has a show all subscription function, and you can clearly see that there is something called auth service, which is your sandbox. And the module is actually asking the sandbox that, am I authenticated to show all the channels to the user, right? So this is not a part of the module itself, but it's a part of the sandbox. So this is what sandbox does. It provides a consistent interface, it provides security, and then it also helps communicate among the modules. And I'll discuss the communication among the modules in detail. So I would suggest to take the time to design your sandboxes. You only have to think of what can be changed in this application, right? So you have to carefully design the interfaces. The internal functionality might change, but that does not matter, right? As far as the interfaces are consistent, it's all good. Now the application core. And the application core is really important, but all it does is it starts the module and ends the module. It's just another piece of the puzzle which kind of controls the life cycle of a module, right? Application core is responsible for the life cycle of each module. Basically tells the module when to start, when to stop. So when the page loads, it's going to tell everything to start. When the page unloads, it's going to tell everything to unload. Maybe it's going to do something in between, like we talked about dynamically loading the module, right? So that's also a part of the application core, because it actually manages when the module starts, when the module ends, right? It's very rare that you start something and you never want to do anything with it again. And it's almost every time whenever we load a module, we do a bunch of changes. We might want to pause a module. We might if the module has been messed up by something, we might want to restart it and all that stuff, right? Dynamically on the page. All of that is controlled by the application core. So it usually has this register method. This is some pseudocode again. So it has a register method, it has a start method, and it has a stop method as well. And maybe you can have a start all and stop all method in your application core, which will help you when the page loads for the very first time, right? So that it starts all the modules and it stops all the modules and the page unloads. So when you bootstrap the application and start up the application, you will see something like this. You will be registering all your modules through the application core and then calling the start all function. The application core manages communication between modules. Let's look at the YouTube interface once again. So if I type in something in the search box, that might affect two places. You might want to change the recommendations, you might want to change the channel subscribe depending on what the user searched, right? Also, maybe if I clicked on the log out button, that also impacts your recommendation as well as your channels, right? When you log out, after that you don't see user preferred recommendations. You see recommendations depending on user location, or maybe your browser settings, or maybe your history, right? So these are kind of those crazy communications that happen between the modules. So if you look at the code, we have this change search text, right, which we just did, which actually calls the recommendation module and asks it to update the recommendations, right, and pass in the text whatever the user typed. And in the recommendation module, you have this update recommendation. Is this good? This is tight coupling, right? Because the search module is directly asking the recommendation modules, which is not a preferred way. We talked about loose coupling quite a lot, right? This is tight coupling. So there are two popular ways to go about it. So how many people have heard of the term Mediator Pattern, just out of curiosity? Okay, awesome. Mediator Pattern is actually the little known, less popular cousin of observable pattern. The mediator pattern basically says that each of these objects only know about the mediator, and the mediator tells any module that, okay, this is the message you wanted to hear, so this is what has happened, and now you can do whatever you want to do. We'll look at the code and that will actually help us understand. And the second way is using shared service state, which is the preferred way. We'll compare both of them. So now I'm converting the old code into this new code, which is loosely coupled. And now you can see that the search module only has access to the sandbox, and then it's yelling and asking the sandbox to notify everybody that something has changed in the search bar, right? This is exactly similar to if you have used Angular. This is similar to doing event emitters and doing broadcasts and emits and all that stuff. So you actually notify everybody, whoever is interested in listening for a search term change. This is the name of the event, right? Now, this is the recommendation modules. All what it does is it actually listens for that particular event, right? So a module can listen to more than one type of events, which in this case, if you see the update recommendation method, you can clearly see that I'm checking in the case what kind of event has happened, right? It's listening to one event for now, but you can have a bunch of sandbox.listen in this place, right? And then in update recommendation, you actually check why am I updating the recommendation. Is the event search term change? Then I will update the recommendation like that. I just talked about that if you log out, this recommendations change, right? That will be another event fired from the logout module, right? And there we will say, okay, the case is logout, then update the recommendation depending on whatever event happened. This is true loose coupling, but this is the first way you can do loose coupling. The event data is So in this, so the way which we just saw, the problem with this thing is you're passing in the data with the event. So the event data is being passed all over the place. And trust me, I have done like a bunch of huge applications. And when you have like tons of modules, you make a mess of it, and then you don't know which module is firing which event, and then you see unexpected things happening because maybe like 8 modules are listening to one particular event, and you don't know where is it being fired from, and then you have to go through your whole application and see where exactly that event was fired from. So a preferred way is to use a shared services state, which actually uses the mediator pattern, but it does something different. So if you see there, I'm actually saving whatever was typed by the user in the sandbox, and sandbox is just a service, right? So you actually persist the event parameters. Is it okay? Are you guys with me, right? So you're actually persisting whatever data was related to that event, right? And then again, you are still notifying everybody, whoever wants to listen to this event, they can actually listen to this event. So now you don't pass the data with the notification, right? And then whoever is interested can go to that particular sandbox and then read the data from it. The benefit of that way is you actually persist the data, and then you have the last state of that event saved in a service. You don't have to actually pass the data all over the place. The application core also handles errors. This is really important as you go to build large-scale application, because you don't want to have like one-off error handling in your code. So always assume that your code will fail. I'll not go into detail because I have a bunch of other stuff which is more important than this. But always assume that your code will fail, and people do exactly the opposite. Like, I'm the best guy, my code will never fail. This is the usual way of thinking about it, but just do the opposite of it. Your code will always fail. Handle errors at each level. You need to handle errors at the sandbox level, as well as the module level, as well as the shell page level. So there are all different levels of handling errors. And report errors and exceptions, and keep a distinction between exception. Exception can be a violation of a business rule, but error can be something that you messed up and you divided something by 0, right? Which all of us did at some point in time. So you divide something by 0, and this is an error. So you got to make a distinction between those two and provide a different UX for both of them. Try and catch, our most favorite stuff. That not always works. It does not work when it comes to async programming. If you have ever heard of it, and if you have ever done async programming, try catch fails there, because you make a request and then you don't wait for the response to come back, and the response comes back like after 5 days, right? And then the code has already ran, and then that doesn't work. We'll see what we're going to do. So these are like a bunch of jobs that the application core has to do. Manage the life cycle, enable inter-module communication, like the 2 ways which we just discussed. What are the 2 ways, by the way? What are the 2 ways we discussed of communication between the modules? Awesome. People are still there. And then general error handling, and then a bit on state management. And then also your application core needs to be extensible, I would say, because these are not all the things application core has to do. The things that I showed are the only thing that application core must do, but there are other things as well. And digital photography and Canon and the DSLRs are the best example of extensions. All the cameras are built with keeping extensions in mind from day one. And the best part about DSLRs is you can pull off one lens and then pull in another lens, right? So the interface is the same. It's a lens. The machine, it does actually the same thing. It takes the picture, right? So by changing the lens, you don't change the functionality, right? So your interface needs to be consistent, and then you can plug and play any lens in and out. So let's say what kind of extensions we can do in application core. We won't be discussing all of them, but only the top two. So state management and AJAX communication. So let's say, let's talk a bit about state management. I can't emphasize more on this, but it's getting really crazy as single page applications are evolving, how people are managing states. I would like you to think that there are two states when it comes to single page application. One is the state of your UI, and one is the model state on the server, right? Let's go through this real quick. So you have, suppose YouTube is using NoSQL, just for a second, don't tell anybody. And there are three collections, collection A, B, and C, which have like a bunch of documents. Now, those documents get converted into some sort of UI, right? Some sort of modules. And you don't see all the documents on your UI. You actually see, like, after filtering all those documents, you see a bit of the data on the UI, right? So you have a model A, and then you have model B. What happens is, you kind of filter the data on the server, maybe in Mongo or Couchbase or SQL Server, whatever, and then you render it on the UI state. Now the state of the UI is not exactly the same as the data that you have on the server. So that's why I'm asking you to keep these two in separate. So UI state is one thing, and the model state that is on the server, that is the actual data, that is another thing. Now the UI state, every UI component on the page, every module has its own state, right? And then you have to actually manage that. The problem with UI state is it keeps on changing, right? We talked about communication between the modules, right? One module can change the state of another module can change the state of another module, right? And every time the state changes, that particular module has to re-render. And then there's a concept of virtual DOM. Who has heard of virtual DOM? Awesome. Looks like you guys are working on React, right? You need to talk to me. Anyways, React took this term from Polymer, by the way. That was called Shadow DOM. It's called virtual DOM. I don't know. Anyways, so what it does is it helps you not to re-render the whole module, right? So you have the model state, and then you have the DOM, and then in between that you have this virtual DOM. It's very expensive to re-render DOM. So what they do is they have this object in the middle called virtual DOM. Every time you make a change to the model state, so what virtual DOM does is it's basically an object which kind of mimics your actual DOM, and then all the changes from model state come to the virtual DOM. Every time virtual DOM actually diffs, like takes a difference of what was the state of the virtual DOM before and what's the state of the virtual DOM right now, and then only passes those changes to the DOM. And this is exactly what React does, like not in great detail, but just an abstraction. Let's talk real quick about AJAX, and after that we'll wrap up. So AJAX is something that has constantly evolved over time. So there are three parts that need to be in sync whenever it comes to AJAX. A request format, an entry point, a response format. And I hope you guys are aware of that. So there was some time, like 10 years back maybe, we used to do SOAP and such. And then we had a request like this and a response as crazy as this, like as verbose as this. And then every time we had to parse this response, right? Every time we have to make a couple of bunch of things to parse that. So these are the three components: an entry point, a response format, a request format, and a response format. Even if you try to use a library like Ajax or anything else, Ajax really works, by the way. So you're kind of, Ajax will help you abstract it out, but it's still you're adding another thing, right, which you have to actually manage. So this should be given to the application itself. So what I did was I abstracted that in the sandbox. Now again, you have a consistent interface to make a request. So you say sandbox.request, right? You don't care whether you actually make a request by doing XML HTTP, you are using Ajax or whatever. In this previous implementation, you were stuck because you were using Ajax, and who knows how long will Ajax, who knows how long will jQuery live, right? $.ajax. In this implementation, you abstracted out the Ajax implementation, and you are giving this responsibility to the sandbox. So all the modules who are actually making HTTP requests, they do not need to change because you abstracted that out in the sandbox, right? So you need to make the HTTP call request change only in the sandbox. You don't need to touch any modules who are actually making those changes. Another way of making a request is promises, if you have heard of it. So you make a request and then you do a then, dot then, and then dot then, and then you do a dot catch. This helps you avoid callback hell. I don't have the time to discuss what is callback hell, but then you have a callback within a callback within a callback. It's callback hell. So you avoid that by using promises. So these are a bunch of jobs that Ajax extension is doing, which I just showed. It kind of abstracted out how you make a request, how you get the response back, and then you don't have to worry about how to parse the response, because that's not the job of the module, right? So whenever the response comes back, I think I missed this point, which is important. Whenever the response comes back, right, every time you have to parse through whatever the response is, whatever the object is, and that should not be done in the module. That is also a part of the extension, the Ajax extension that you build. So this is, and then we have base library left, which is actually your jQuery or Angular or whatever you want. So this is the wrap up. So the base library is the only part which knows which browser is being used. Any place else in the architecture, you don't want to have checking whether it's Safari or anything else, so it kind of abstracts it out, and then you don't worry about any browser or anything. And then we talked in detail about application core, sandbox, and the module. I don't want to repeat that, trust me. This is the most important part of my presentation, and my presentation starts right now. So you have 7 minutes to concentrate. So I always try to do this. I do some talk, and then in the end, I have some bonus points. So these are the 2 bonus points, the 2 takeaways. If you think that the whole presentation was a crap, forget about that. Talk to people about this after the presentation. First thing, you should know about the term isomorphic applications if you want to learn modern web application architecture. So we have a view in which we do HTML, CSS, whatever, and then we have JavaScript. And then this is the server, the green box. You can write Java, you can write C#, you can write Python, Ruby, whatever. And then you can still write Node.js as well, right? And then on this side, you have the database, which can be SQL Server, Oracle, whatever. Which can be an XML as well, but also it can be a NoSQL database. It can be MongoDB or CouchDB. Think of this. How about writing the same language all over the place? And this is real. You can really do it. Companies as big as Google, if you think PayPal is big, and some other companies. All of them are doing this. And this is awesome because it helps you share your modules across ends. Whatever you write here can be used here and can also be used there as well. So this is one thing, isomorphic applications. The next is reactive functional programming, and we'll do a crash course in 3 minutes. And you should go and learn about reactive functional programming because that is the next hard thing if you want to stay in this industry. So we have let me do this like this. So we have a variable A and then a variable B. And B is dependent on A, so B becomes 100. But the problem is A can be mutated, A can be changed, updated. And now A becomes 20. What's the value of B? Anybody?
100.
It's still 100. B depended on A, but it never got a chance to know that A also got updated, right? So every time A is changed, we have to tell B that A has changed, which is a problem. How to solve this? Use Excel, forget about programming and everything. So Excel is the most powerful tool to do programming, that is for non-programmers. And it has done this thing like since forever, right? You write a formula from B, and then every time you change A, it updates B, right? This is the behavior that we want in our application. This is exactly what reactive functional programming is. So how we can do that? Forget about what map is, but this is something which helps you do like reactive programming. There are a bunch of functions in functional programming like filter and map and all that stuff. And this code will help B keep in sync with A. So whenever A changes, now you don't have to tell B that A has changed. Every time A changes, this thing runs and then it's mapped to B. So there are like 3 things. What A is B is depending on A, and then it needs to have a current state and it needs to have a formula to apply. Every time A changes, this formula gets applied and then B gets updated. This guy, there is no other guy in this world who can talk better about functional programming than this guy. So go and check out his Gist and GitHub and all that stuff. So everything is a stream of events and you can go reactive about it. So anything that can happen over time, like clicking on the page and then intercommunication between modules, like one module updating the other module, think about it in those terms. So anything, any event that happens over time, you can make it go reactive. And reactive programming will take over this world in 5 years. This is my prediction. Last slide. By the way, your app is up, youtube.com, check out. It's up. Any questions?
So why do you think reactive is going to take over in 5 years?
Because there are a couple of things that we have been doing in programming that are not easier to reason about, like I just showed the example, right? So whenever something gets updated, right, like think of this in terms of communication between the modules, right? When one module changes, it wants the other modules to change, right? So the 2 ways that we have today are what? You emit some notification and then this thing says, okay, this I want to get notified, I'm a subscriber and I'll change it, right? This is something that we do. This is kind of a hack, but it's not easier to reason about, right? Every time you have to write .listen, .subscribe and stuff like that. Reactive programming, on the other hand, is kind of, it gives you that intuitive feeling, okay, this is mapped to this, like the example that I showed. So B is mapped to A. You don't have to kind of subscribe to A, right, all the way. You get my idea? So it's, I would say it's like more easier to reason about. React banks upon it. Angular is like pushing the whole Angular 2 framework using RxJS, which is a reactive framework. So this is from my side. So anything else, anyway? That's it. Thank you.